In the previous video, I have given you the value of resistivity. What is that? Rho is equal to m by n e square tau, where m is mass of an electron, n is number density, that is number of electrons per unit volume, e is charge of an electron, and tau is relaxation time. In this video, we will see how does the value of resistivity or resistance, both are connected, right? How R is equal to rho L by A. So resistance is equal to resistivity into L by A. Now in this video, we will see how the value of resistance varies with temperature. On increasing temperature, what will happen to resistance? And we are going to see the same thing for conductors, semiconductors, alloys and electrolyte. Will it behave in the same way or in different way? Now, what is the reason for resistance or resistivity? The reason is very simple, that whenever electrons move, charges move, that is the reason for current, right? Whenever charges move, they collide with another atom or another moving electrons. So whenever that happens, that is basically a hindrance or an opposition for the movement of charges. That is the reason for resistance. Now, when we are increasing the temperature, what will happen? These electrons will get higher energy and they will move at faster rate, and even collision will be more. Now, in the previous case, let's say if there are 5 number of collisions in 1 second, now when we increase temperature, number of collision will become 10. Or I could say that the time taken in between 2 successive collision will decrease. What is that? Relaxation time. Previously, if it took 2 seconds for a collision, now it will take only 1 second for the collision, because higher energy, that leads to higher number of collisions in a second. Now that itself gives us the value or gives us the conclusion that whenever we increase temperature, number of collision will increase. Number of collision is basically in opposition for the current flow, which means the resistance will increase. So we have conceptually proven that resistance will increase for a conductor when temperature increases. Now we will check the value, the validity of this fact with the equation. Now as I have told you, when temperature increases, the relaxation time, what is that? Time taken in between 2 successive collision decreases. Now see, tau decreases. Now this value when decrease, the whole value will increase, which means resistivity will increase with increase in temperature. Okay. So in the case of conductors, resistance or resistivity increases with temperature. Okay. Now we will see in the case of semiconductors. We will use the same equation. Now in semiconductors, what are semiconductors? Elements having 4 valency. So basically they have very less number of free electrons. Now how can we generate free electrons? By increasing temperature. So generally charge carriers are very less, number of free electrons are very less. When we are increasing temperature, more number of free electrons are generated. Now the value of N become higher. Now the total value of resistivity will become lower. Now you can ask me, sir, at the same time tau will also decrease, right? But increase in number density of electron will be more expressive or more relevant as compared to decrease in relaxation time. This is an exponential increase. This is related to T power 4. Okay. So when there is a small change in temperature, more number of free electrons are generated in semiconductors. At the same time, decrease in relaxation time will be comparatively less, which means the resistivity decreases or conductivity increases. So with semiconductors, I could say, I am going to say here in this case, resistance is directly proportional to temperature, but here in this case, resistance is inversely proportional to temperature. When resistance increases, when temperature increases, resistance decreases. These are not, I could say that inversely connected, but this value, this relation we can't make here, because we can only do that after getting an expression. Okay, so here it is directly proportional, it is inversely connected. In the case of electrolyte, what will happen when we increase temperature? What is electrolyte? For example, HCl solution, H plus and Cl minus. We know in a solution, what are the charge carriers? Ions, H plus and Cl minus are charge carriers. Now, this is a solution, right? When we increase temperature, what will happen? The viscosity will reduce. For example, we have, what is a viscous solution? For example, we have honey. In honey, when we move our hand, no, we have higher opposition. But when we do the same thing in a rarer media like kerosene or water, we can easily move our hand, right? So honey is a viscous fluid. This one is a less viscous fluid. Which one? Kerosene and water. Now here in this case of solution or electrolytes, when we increase temperature, viscosity reduces. What is viscosity? Fluid resistance or resistance towards movement of fluid particles. Clear? Which means when temperature increases, it is easy for the particles, ion, to move across because of this less viscosity. So that gives the value of, that gives the explanation for why resistance decreases when temperature increases in electrolytes. Clear? So we don't have to get a mathematical representation for this concept. If concept is clear, if it is asked in your question paper, then you can give this as the explanation. That is, it is connected with fluid viscosity. Whenever temperature increases, viscosity reduces. For ions, it gets a smoother passage now, or it can move from one position to another position in a smooth manner. Okay. Now, in the case of alloys, alloys are nothing but combination of two different elements having two different properties. Okay. In the case of alloys, temperature dependence will be less as compared to conductors. This will also increase its resistance with respect to increase in temperature, but not exactly like conductors. In the case of conductors, for example, I will take the example of copper. Now, it will increase, see, like this, kind of exponential graph. With lower temperature, it is slightly less, but as we are going for higher temperature, the temperature dependence is higher, or variation of resistance will be higher in this case with conductors. For copper, this graph is very important, where here it is resistivity and here temperature. Now, with some alloys like nichrome, it will be like this. Okay, it is dependent, resistance is dependent with temperature, but compare the slope is less, which means higher dependence over temperature, lower dependence over temperature. Okay, with semiconductors, so both are increasing over temperature, right? Now this is for copper. Copper is nothing but a conductor, pure conductor. This is for nichrome. Nichrome is nothing but an alloy. These two graphs are very important, and at the same time, what will happen in the case of semiconductors? We have proved that with semiconductors, resistivity will decrease when we are increasing temperature because more number of charge carriers are released now. So these three graphs are important. This is semiconductors. Semiconductors. Now this is resistivity, temperature. In the next video, I will give you the equation, that is mathematical representation for variation of resistance with temperature. Thank you.